Good afternoon and welcome back to Precalculus. At this point, you're either ahead of me and listening to this early, or you've already met with me today and you're getting on to today's lesson. Either way, welcome to our first lesson in our review chapter to Precalculus. All right. So here's the biggest thing that people don't get. When they hear math, they think numbers. But the real basis of math is not numbers. Math is not actually numbers. Math is sets. Sets are simply groupings of things. We group colors together. Your crayons are all different colors and they're grouped in a box. It's a set of crayons. You can group pens. You can group cars and animals and phones and clothes and just about anything you can think about. Math is based in sets. And yes, we have sets of numbers, and sets of numbers are often what we will talk about when we're doing math. But that doesn't mean that we're limited to sets of numbers. And this is why I told you in our introduction that we would get into spaces in math where some of the math rules that you know won't work. Because if you're thinking about putting colors in order, you could put them order by wavelength, you could put them in order by name, you could put them, but the order changes. And so numbers, you know that 2 is less than 3, but you don't know that blue is to the right of red. And so these kinds of things are areas where there's some gray spaces in math, but the number systems are usually what we are talking about. Normally, we will be talking about things like the natural numbers. All right, so we have to look at notation before we do very much here. So I'm going to turn on my pen here so that I can talk about this. Sets are usually represented by capital letters. So in this case, you might see things like S or capital A, etc. Like down here, I have capital A, okay? The items inside the set are called elements, okay? So I can have elements inside each of these. So inside S, I could have all the different shoes I own. And then inside A, I could have the homework that's due this week, okay? So these are simply groupings of items. They don't have to be numbers. Now, the numbers that we primarily will be using and talking about would be things like the natural numbers, and we write this in a special way with a special capital N. This, using the notation, we use braces. That's this shape. And then we would write the elements. So natural numbers starts with 1 and then goes till 2 and then 3 and 4, and it keeps going forever to infinity. And these are the natural numbers. You've also heard of the real numbers. The real numbers will be all the decimals, all the rational numbers, irrational numbers, that kind of thing. And we have Q for the irrational numbers and I for integers and all these different things. So, elements will be listed inside these braces like what I've done for the natural numbers. And this simply means 1, 2, and 3 are elements of this set. All right, so let us look at some problems here. Problem number 1. J is the set of whole number multiples of 3 that are less than 15. So let's start by writing out what is J. J. This is going to be, we have to write our braces here, and whole number multiples of 3. So then there's 3 times 1, so that's 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15, but this says less than 15. That means 15 won't actually be in my set. So this is my set J. Now, I'm asked true or false, is 15 an element of J? This symbol is asking, is this an element? So I'm going to look at J. Is 15 one of these elements? No, 15 does not belong to J. So this is false. Let's try this again. K is the set of consonant letters in the English alphabet. Is H an element of K? And I need to say true or false. So we're going to start by writing K. K is, don't forget your braces. A is a vowel, not a consonant. B, C, oops. Let's switch that around. My writing here is new. I don't know what happened. Nope, it's not working. So my button doesn't work. Well, I'll figure that out later. And we'll write this again. Turn back my pen and C, D, E is a vowel, F, G, H, I is a vowel, J, K, L, M, N, O is a vowel, P, Q, R, S, T, U is a vowel, V, W, X, Y is not really a vowel, Z. And then we put our bracket on there. So there is my first thing. Forgive my poor handwriting. I am still getting used to my little pen pad here. All right, so I've got K is this set. Is H an element of K? Well, H is right here. So yes, H is an element of K. This is true. All right, next problem. V is the set of the states in the U.S. that border Georgia. So now our question is, do you remember all the states that border Georgia? I know you guys are closer to Georgia than me. Do you remember them? I didn't, so I brought this up. Yes, I have tricks up my sleeve. Okay. So here we have Tennessee, North Carolina, South Carolina, Florida, and Alabama. So Alabama, Tennessee, North Carolina, South Carolina, and Florida. Oops, notice parentheses are wrong. If you do that in Alex, they will be very upset. In fact, there you will have a button so that you can click the button and it will put both braces on at the same time. So now I can put this brace on. Is Alabama not an element of V? Well, Alabama is in V, and so then this is false. All right, so as we're going through this, we're simply learning how to read. And do you notice none of these were numbers? Okay, the first one was numbers. But still, these are sets. This is what math is actually based on. And believe it or not, I am still working in sets in my class, and we start at the beginning of the year, and we're still trying to figure out numbers from sets. All right, next slide. Notation again. So we already talked about element and not an element. So here's the element, here's not an element. This is a subset of. So if you see this between A and B, so if you saw A and then this weird C and then B, that means every single element of A would have to be inside B. I'll show you an example of this in a minute. Now, A with this thing here, we often call this prime. A prime means the complement of. That means everything that's not in A. So as we're going through this, you're going to have a universal set. So for example, over here, usually we say this is the set space and it's U. Okay, everything that we can possibly have is in U. And then inside here, we'd have A. And this is A. If this is looking like a Venn diagram, believe me, that's where we're going. So anything inside here is A. Anything not in here would be A prime. So all of this would be complement of A prime. You can also write, and so A prime, you might also see A with a line over it. That means the same thing. You may also see A with a little C up here. All of these notations mean the same thing. It simply changes depending on how far you are in math and the program you're using. Our book uses this form. Alex uses this form. Here, what I'm using is this form, so you may see this if I slip up. But I'm letting you know all of these mean the same thing. It means everything that's not in A. All right, this notation. This means the things that are in A and the things that are in B, but not the stuff that's only in one. So over here, I'm going to put another thing B. Okay? For the intersection, it would only be these things in the middle. Anything that's not in the middle is not in the intersection. Okay? The intersection is literally this part where they overlap, where the two circles intersect. Okay? And then we have the union. Let me change my pen color here. Come on, pen. Let me change your color. There. Okay, so the union here, if I were to look up here for the union is everything that's inside A and in B. So all of A, all of B, and what's in the middle. Okay, that is the intersection. Or sorry, that is the union. That is A union B. Okay? So let's practice using some of this notation in a few problems here. But before I get there, I want to talk to you about this set. So I was trying to draw this a moment ago. But if you look here, I am looking at a universal set. So I'm going to turn this to a laser pointer so that you can see where my cursor is. If you look here, this is the universal set. So everything that you can possibly list is in this box. Okay? This is set A. And this is set B. Do you notice that everything in B is also in A? This is what subset means. It means B is a set inside A. Now, we don't use the little element symbol, which looks similar, because if we did that, we'd say that this is an element. But this is not an element. It's a set with its own group of elements. So B could be the even numbers, and A could be all the integers. And so A is even and odds, and this is just even. But neither one is just one element. Okay? So this is an idea. Also, if you look here, you can see all of this is shaded. It's slightly different color blue. What is shaded is the complement of B, or B prime. Everything that's not inside B is what's shaded a lighter color blue. All right, are you ready to get to some problems? I know this can seem a little bit confusing, a little bit hard, but we can do this. All right, so I pulled some problems out of your book. I know you don't have a book. I don't have a book. We're in the same boat. But I found the problems. So we're going to work through some of these problems together. So first of all, we need to look up here at our set. This is our universal set. We are counting from 0 all the way up to 12. Okay, that is our set. we aren't going to have anything else but those numbers. So when I'm asked to find the complement here, the complement of C, I need to take the universal set and anything that's in the universal set but not in C, so not these numbers, that will be my complement. I know I'm going in detail, but this is good for you. So here's equals, and now I'm going to use set notation here, and 0 is in C, 1 is in C, so I start with 2, 3, 4, 5, 6 is in C, 7, 8, 9 is in C, 10, 11 is in C, so I end with 12. Okay? I will do the same thing with A. If I look here, this is what A is. Okay? And you can do that on your paper. Now, one other complement here that I want to deal with is U complement. This is everything in the universal, or everything that's not in the universal set. So if you look at these numbers, 0 to 12, what number in 0 to 12 is not there? They're all there. So this is the empty set. Now, it's kind of confusing when you write your braces like this. That doesn't make sense. So what we normally write is a circle with a line through it. This is the symbol for an empty set. This means it's a set with no elements. Okay? Now, C intersect E. So I need to look at C and look at E right here, C and E, and see what matches. So 2, 3, and 6, 1, 0, 6, 9, 11. The only thing that matches, the only thing that's in both is 6. So C intersect E is going to be 6. And don't forget to put it in set notation. Okay? E union F. This means all the items in E and all the items in F. I think of this as a cup that catches all of it. So I'm going to look at 2, 3, 6, 2, 9. I've got 2 listed twice. But it doesn't matter if it's listed once or twice. I don't list it in the set more than just once. Okay? So I go 2, 3, 6, 9. This includes every element in F and every element in E. You can see here's E and here's F. Okay? You can work the rest of those if you would like. Now, what if we have a crazy Venn diagram like this? Okay? So, in this Venn diagram, we have the list of numbers from 1 to 15. That is our universal set. If you notice up here, we have universal. That is our set. These numbers in the white right here, all of these numbers are there because they are not in one of the sets, A, B, C, or D. So if I'm looking at A union B, I am going to look at everything in A and everything in B. So A has 1, 3, and 6. B has 2, 6, 7, 9, and 10. So in this 1, 2, 3, 6, 7, 9, 10. Okay? Now, how about this one? 29 looks kind of interesting. Well, let's do 26, and then I'll go and I'll do some other ones. Pen is, there we go. So, A intersect D. So I'm looking at A, and I'm looking at D, and what is in their intersection? Well, inside the intersection is right here. It's going to be 1 and 6. So A intersect D is simply going to be 1 and 6. A complement. I'm not going to write a complement for you, but I'm going to show it to you. So here's A. A has 1, 3, and 6. Whatever is not in A is A complement. So every number except 1, 3, and 6 would be in this list. But I want to look at some of these where I've got these unions and multiple things here going on. So A intersect B intersect D. So I need to look at A, B, and D and what matches. So let's look at A and B, and in their intersection is only 6. Okay, when I'm looking at this, I'm going to get this intersection right here. Do you see D covers 6, B covers 6, and A covers 6. So this intersection is simply the set with only 6 as an element. And then what about these unions? A, union B, union C. Okay, so I'm going to start by listing A union B. So A union B is 1, 2, 3, 6, 7, 9, 10. And then I need to union C. Well, 1 is already there, and so I add 11 and 12 to my set. 11, 12. Yeah, I'm going up the hill. I realized my pen is going to hide in this color slide. All right, let us move on. Academics, yes, this is where we get word problems. There are 26 students at the West High School who take either calculus or physics or both. Each student is represented by a letter of the alphabet below. Draw a Venn diagram of the situation. So I have all of these letters listed out. But if you look carefully, you see D here and you see D here. That means I'm going to have some intersections. So I need to draw a Venn diagram. Well, I told you I had some tricks up my sleeve, so there's my Venn diagram. Woohoo! All right, so over here, I'm going to say this is calculus, and this is physics. Okay, now I need to list. A is only in calculus, so A goes here. B is only in physics, B. C is only in physics, C. D is in both. E is only in physics. F is in both. G is only in physics. H is only in physics. I is in both. J is in both. K is in both. L is in both. M is only in calculus. N is only in physics. O is only in physics. P is only in calculus. R is only in calculus. And you get the idea. We're just going to list all of these numbers, okay? That's how you draw, or all these letters. That's how you draw the Venn diagram for this system. This situation. All right, next problem. The Venn diagram shows the memberships for dance, chess, and science clubs. Use the diagram to answer the questions below. So select all the clubs that Kiko is a member of. So I'm going to look for Kiko here. Kiko is here, only in dance. So only a member of dance. How many students are members of the chess club or the science club? Okay, the or in that situation means that I can be in the chess circle or I could be in the science circle. So I can be in one or the other, or even both of them. I can be in this area. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 students in both. Which of these students are only in one club? Well, I don't get to see the list of what students they're talking about, but the students in only one club would be Kiko and Amy, Tony and Scott, and Rita. Because notice all of these others are in at least 2 clubs. Susan and Ann are actually in all 3 clubs. This kind of question is the kind that you would see on Alex for the homework for today. This is another one that's similar. So the number cube with the faces labeled 1 to 6 is rolled once. The number rolled will be recorded as the outcome. Consider the following events. Event A, the number rolled is even. Event B, the number rolled is greater than 3. Okay? Well, to come up with this, I need to decide what my universal set is and what my events are. And then I can figure out the ors and the ands and the complement. So I'm going to draw a Venn diagram. Now, I know I can roll 1 to 6. 1, 2, 3, 4, 5, 6. This is my universal set. This set, every number from the set has to be put in one of these. So this is my U. Okay, again, outside here is U. Here's where I'm going to put A. Here's where I'm going to put B. So the number rolled is even is A. The number rolled is greater than 3. So greater than 3 is going in B, even in A. 1 is not even, and it's not greater than 3. So 1 is simply going out here in the universal set. 2 is even, but not greater than 3. 3 goes out here because it's not greater than 3 and it's not even. 4 is even and greater than 3, so it's in both. 5 will go in just greater than 3 because it's odd. And then 6 goes in both again. So here's my picture. So now, event A or event B, okay? What are the outcomes? And we need to list them in set notation. So what outcomes give me a success? Whether it's A or B, I don't care. So 2, 4, 5, and 6 are all correct answers. So 2, 4, 5, 6. Event A and event B. This means both answers have to be right. So this is only in the intersection right here. 4 and 6 would give me the correct answers. Now I listed them this way. I want you to realize order doesn't matter. Up till now I've been putting things in numerical order, but you don't have to. So I can list them in the wrong order and it will still be correct. It makes my grading job a little bit harder, but it's still right. So the complement of event B. So I'm looking here for event B, and since I need the complement, that means B with the line over it. So looking over here, what's not in B? Well, 1, 2, and 3 are not in B, and so this is 1, 2, and 3. All right, next and last problem. A marble is selected from a bag containing 8 marbles numbered 1 to 8. Are you recognizing this problem? All right, if you see that this problem is similar to the last one, go ahead and pause the video and see if you can solve this one. All right, so I'm going to go through and solve this really quick. I brought my Venn diagram, and in my Venn diagram, I have my universal set. I have set A and set B. I've got 1 through 8 is in my universal set. A is if the marble selected has a number less than 4. And B is an odd number. So 1 is in both. 2 is in A because it's less than 4. 3 is in both. 4 is not less than 4. So 4 is in my universal set. 5 is an odd number. 6 is in my universal set, 7 is an odd number, and 8 is in my universal set. So here's my picture. Event A and B. So both have to be correct. The only answers are 1 and 3. A or B. This is 1, 2, 3, 5, 7. Complement of A. This is 4, 5, 6, 7, 8. All right. And that is today's lesson. Go ahead and do some of the problems in your learning pie and work on the homework for today. If you can go forward to the next lesson. I will talk to you again tomorrow.